Okay, we're going to cover the topic today of multidimensional arrays. And we've talked about arrays before, and we've talked about how in C, arrays really evaluate as an address of a block of memory. And today we're going to talk about multidimensional arrays. So rather than an array that's like a linear array of just elements in a line, think of a two-dimensional array as like a grid of values, or a three-dimensional array. You can think of it like a volume of values. And you can really have arrays of a lot of dimensions, 5 dimensions, 6 dimensions, however many you want or need for your application. But what we're going to see is they work in a similar way from what we're used to with the typical single-dimensional arrays. But there's a little bit of a catch here. So let's go ahead and continue on. All right. So multi-dimensional arrays, C allows multi-dimensional arrays. And just like with single-dimensional arrays, multi-dimensional arrays are stored as a contiguous block of memory. So in other words, if we make an array with 2 dimensions or 3 dimensions, it's all the memory that is available for all those elements is all one big block of allocated memory. In other words, it's not divided up with some here and some over there and one row here and one row over there. It's all one big block of memory. And the name of the array, just like with single-dimensional arrays, evaluates as the beginning of that block of memory where that array is stored. Now let's look at a couple examples here. All right, so here's an example of declaring a multi-dimensional array. And the way you notice you do this is just like with a single-dimensional array. Here, int AR1 is the variable name, the array name, and this is 3 and then 5. So this is a 2-dimensional array that is 3 by 5. In other words, this is a 3-element array where the individual elements arrays are 5 elements each. So in other words, you can think of this as 3 rows where each row has 5 elements in it. And here's a 3-dimensional array that's a character array. Notice that the array still has to have a type. This is an array of integers. This is an array of characters. So this one, AR2, is 3 by 4 by 5. So this is a 3-element array of 4-element arrays of 5-element arrays. So this is, think about this like a volume that has 3 sets of 4 sets of 5 things, of 5 characters each. And here's another one, a 2-dimensional array, AR3. That's a float array, and 365 by 24. This might be, for example, if we want to store temperatures, a temperature every hour for every day of the year. So in other words, we want hourly temperatures stored for every day of the year, 365 element array with 24 hours in each one of these days. So those arrays can also be initialized when declared. So here we declared them uninitialized, and this is important, just like with every variable in C, that if we allocate a multi-dimensional array like this and then we don't initialize it, it starts out being just garbage values. It's going to have just garbage in it, whatever happened to be in memory. So we can initialize when we declare them. So for example, here's an array 2 by 3. So here's 2 sets of 3 elements each, of 3 integers each. And in this case, I went ahead and initialized them to 0, 1, 2, 3, 4, and 5. So the first row is 0, 1, 2. The second one is 3, 4, 5. And in memory, that would be stored like this. So 0, 1, 2, 3, 4, 5. Again, contiguous in memory, but organized as 2 groups. So here's group 1 over here. Here's group 2 over here, and each of those groups has 3 elements each. So looking at the indices of that, though, which we'll look at in a second, again, here's that being stored. So if I were to index into that, I basically use the same square bracket notation to index into the arrays that I would use as single dimension. So AR1 subscript 1 subscript 2. What element is that in here? So in other words, this is group 1, which is the second one, index 1 for the group, and then this is the element within that group. Now, the way that this works behind the scenes for the compiler, if you remember back to how arrays work, they just do a form of pointer arithmetic for us. So if we were to look at that, it's like saying square bracket notation is doing pointer arithmetic of this element plus 2, and then get the thing pointed to by that. And then this, if we expand that, there's a square bracket there as well. We do the same thing on that. So if we look at this, this is saying take the thing pointed to by AR plus 1, and then take that whole thing and index 2 into that. So if we look at that, AR plus 1, well, AR1 here, that is going one group of 3 elements. So that's the first group of 3 elements. So we move over to here. And then from there, we add 2 spaces, and those are integer spaces, so 1, 2. So the place that that's going to be when I expand that is going to be this 5. So this performs pointer arithmetic for us. AR plus 1 gets us to the second block of 3 integers. So this would be AR1 plus 0. This is AR1 plus 1. And then we do plus 2 from there. So 1, 2. That gets us to that 5. So looking at the indices, I have them listed here. So this would be AR00, AR01, AR02, AR10, 11, and 12. And notice again that these indices, or the numbers we put in here when we declare an array, that is not the number of the maximum index. That's the number of elements. So it's always going to go one less than this. So the last thing in this array is AR1, subscript 1, subscript 2, not 2, 3. So we got to be careful we don't go off the end of that array. Okay, so now that we have these multi-dimensional arrays and we can declare them, how do I pass one to a function? And there's a couple ways to do that that we're going to look at here. The first way is to, if we pass it using the name of the array by itself, which evaluates as the address of that array. But when it gets received by the function, if this is statically allocated to be a 5 by 3 two-dimensional array, I need to make sure that my function arguments are set up to receive a 5 by 3 two-dimensional array. And actually, you can leave off that first index there because that's just counting in integer units. So you could leave that off. So this is some number of 3-element arrays. So you could leave the first one off, or you could provide it. It doesn't really change anything. But just note that you can leave off that first one. So if you see that in code like that, this looks like a box, but it's really an empty set of square brackets there. It's just the font. You can pass it in like that, leaving off the first one. But the dimensions after the first one have to match, so the compiler can do the pointer arithmetic, because all this function is getting is an address. So when it gets that address, it has to know how many groups of, how many rows of how many columns are there in order for it to do the pointer arithmetic correctly to get us to the right unit. Now, for all versions of C, those statically sized arrays can be passed as long as all of the dimensions, or all the dimensions except the first, are defined within the function declaration, just like we did back here. And let's look at an example of that again. So here's an example of that where I've defined this array as a certain number of rows and columns. In this case, it's 2 rows, 4 columns. So here's my row 1, here's my row 2. And notice that's statically allocated. Even though these are look like variables, they're not. These are just pound defined, so it's plugging in a 2 in there, plugging in a 4 in here. And now we're passing that to this print AR function, which is going to print this table for us. So that print AR function, when it receives it, it has to know how many things are there in each of these columns, because it uses that to jump ahead by that number of integer units to get to the right row numbers. In other words, we have to know how long a row is to jump the right number of units ahead, so we have to specify that one. But this one, since it's just a row of integers, we don't really need to specify that. So we could put rows here, or we don't have to. We could put it there or not. It would still work either way. But one of the things to note about this code is this is now inside of here. We're just going to go through a number of rows, a number of columns. It's going to print all of the elements out after each row. Or after each row we've gone through all the columns, we print a new line. So this is actually going to print a little table for us that is 2 by 4. So the first row will say 1, 2, 3, 4. The next one will say 5, 6, 7, 8. And if we were to change this, the number of rows and columns to be like 5 by 6, and change these values to have 5 groups of 6 things each, then this would still print out the table properly because we've used the pound defined rows and columns down here. So this, though, will only work as long as this array is the same size every time. In other words, we have to statically allocate that to be a fixed size. So if we wanted a program that could dynamically adjust the size of the array to say sometimes it's 2 by 4, sometimes it's 4 by 4, sometimes it's 8 by 6, this code can't do that because it has to be statically allocated for this to work, because this has to know the size down here. Now, we can write a function that does handle variable-sized arrays, variably dimensioned arrays, but we have to do it a little bit differently. So to pass multidimensional arrays, if we're using C89 and later, the array is still passed as the address of the start of the array in memory. And with the function receives that, we would need to do some pointer arithmetic ourselves on that. So to handle variable dimensions, we would have to pass into the function the dimensions of that array. So here's an example of that. All right, so looking at this, a couple of things are different. I made two arrays. I have AR1 that's still 2 by 4, and then I made AR2, which is 4 by 3. Completely different organization. So this is 4 groups of 3 elements each, where the other one was 2 groups of 4 elements each. Well, we're going to use this same function, this print AR C89 function. And you'll notice the way that I'm passing this in, though, rather than using the square bracket notation with a fixed number up here, I'm passing this in as an int pointer. And the reason for that double pointer on that is because it's a 2-dimensional array. So a single dimensional array we pass as a pointer. A 2-dimensional array is a double pointer to a pointer. So in other words, think of this as the address of something that itself has an address. Now, what are we doing along with that? We're also passing in the size of that array, because we're going to have to do the pointer arithmetic ourselves inside of this function to get to the right element that we want to get to print all of them. So in other words, I'm passing in the address of where the array starts in memory, but I'm also saying, here's how many rows it is, and here's how many columns it is. And you'll notice that the rest of this code pretty much works the same as it did before. We're going through a set number of rows and a set number of columns. In this case, they're changeable, though. But then down here, we're doing some pointer arithmetic on that. We're saying, essentially, take the variable that was passed in, treat it as an integer pointer, and then add to that a certain number of places, in this case I, the number of rows times columns, so how many columns it is, and then plus j. So this is actually moving us the I part is moving us a whole row ahead, because each row has a certain number of units wide, which is indicated by columns. So this is jumping us ahead by rows, and then this is moving us ahead by individual points past the rows, and then we're getting the thing pointed to by that, which is the element of the array we're on. So this code works very similarly, but rather than have the compiler do the pointer arithmetic for getting us to that element, we're doing it ourselves right there. But what's cool about this is this will work for any size array we want. If we had a 10 by 5, we could pass that in as long as we pass in the 10 and the 5, and this will handle doing the pointer arithmetic for us based on that address to get us to the right element that we're interested in. Now, with C99 and later, there's a way to get the compiler to do some of that work for us, so we don't have to do all that pointer arithmetic ourselves. And the way we do that is passing in arguments that can indicate the size of the array, but the compiler is going to perform the pointer arithmetic for us. And that way we can use the square bracket operator to select the items rather than what we had to do back here with doing the pointer arithmetic ourselves, computing that ourselves. Now, the disadvantage for this is we need a compiler that supports C99 and later. So if you want to build your code to be more cross-platform, not matter what version of C the compiler targets, then use something like this one back here. C89, you probably won't encounter a compiler that does not support that, at least that. And really this will work on pretty much any form of C that you could come across. This will only work on C99 and later. All right, now how does this work? Well, we're going to pass in the size arguments just like we did in the previous one, but it's important to note that for this to work, those have to precede the array pointer argument that uses those sizes. Let's look at an example. So notice that the rest of this code up here is the same, except for the name of the function. It's still a 2x4 and a 4x3. But notice that we had to change the order of the arguments around so that the rows and columns comes first. And the reason for that is because those are now used in the sizing of this array back here. So notice we're no longer doing the double integer pointer. We're not doing int pointer pointer. We're basically saying this is an array of integers that is rows by columns. It's a two-dimensional array that's rows by columns, but we have to have this after these so that the compiler has rows and columns when it does the computation for this. And now it's going to do the pointer arithmetic for us. But really what's going on behind the scenes here with this code is that this is just creating that pointer arithmetic thing for us rather than having it where we have to do it ourselves. Some sort of dog activity going on back there. But notice that this is a little bit cleaner to look at. You can say ARI, subscript I, subscript J. That's getting us to that particular element in the array. But again, to do that, these dimension arguments have to come before the actual array declaration up here. Now, we could, in a C99 compiler, still do things this way. This will still work. But notice this is a little more confusing, a little bit more difficult to understand, more room for mistakes and misunderstanding, where this looks more like we're accessing a two-dimensional array. And it really doesn't cost us anything to change the order of these around as long as we know that we have to do that. So the compiler is going to perform that pointer arithmetic on our behalf, so we don't have to do it ourselves like we did over here. Okay, couple final things for today. This will be a relatively short lecture. I am going to post the next lab as well. We're going to use some of these multidimensional arrays. But notice that you could also have arrays of pointers. So here, for example, is an int pointer array that's 5 big. So this is an array of 5 integer pointers. So here's some example code. Int I, int j, AR sub 0 is going to hold the address of I. AR sub 1 is going to hold the address of j. So this is just holding the addresses of these two integer variables. And it can do that because it has spaces for 5 addresses to be stored. And now I can print those out and say, give me the thing pointed to by AR sub 0. Well, AR sub 0 is the address of I, which is holding 10. So the thing pointed to by that is 10. The thing pointed to by AR sub 1. That AR sub 1 is holding the address of j. So the thing pointed to by that gives me j, gives me 20. So arrays of pointers can be useful, as we'll see here in a second. Let's look at some other uses of arrays of pointers. So notice here is an array of 8 character pointers. In other words, we can hold 8 addresses. And notice I'm kind of, when I declare this, I'm also initializing it to have these words. So none, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So day 1 is Monday, 2 is Tuesday, 3 is Wednesday, 4, 5, 6, 7. That's the 7 days of the week. And if it's 0 uninitialized, it says none. Notice that we could also use this for a game. Like, for example, here's, let's say we're making some sort of role-playing game. And we have some sort of karma or alignment for our characters. So, for example, here's my character pointer for the alignment. There are 4 of them: lawful, neutral, chaotic, and true. And then the second part of the alignment might be good, neutral, and evil. So you could have lawful good, lawful neutral, lawful evil, chaotic good, chaotic neutral, chaotic evil, neutral good, neutral evil, and there's no neutral neutral, there's true neutral. But you'll notice that we could store these in our game, all this as an array of character pointers. So the alignment 1 subscript 0 would refer to the address it's holding the string lawful. Alignment 1 subscript 1 is going to hold the address of this string neutral, and so forth. And then we might also want to store the races. So we have dwarf, elf, gnome, halfling, dragonborn, human, tiefling, half-orc, and half-elf. as our possible races. And notice that here I use this square bracket with nothing in there. That allows the compiler to kind of size this array automatically for us as long as I initialize it here. So we're still going to end up with a character array of character pointers that has 1, 2, 3, 4, 5, 6, 7, 8, 9 items in it. And by not putting the index inside there, I could add more of these later and not have to update my code. Okay, one other thing, you can also have pointers to pointers. We actually already saw this back in that C89 example. But notice here is an integer pointer pointer. So this is something that's going to hold an address of a variable or a thing in memory that's holding the address of an integer. So this is a pointer to an integer pointer. Here is a pointer just to an integer, and here's just an integer. So notice how I can use that. I can say set the integer to 5, set the pointer to the address of that, and then I can say set the pointer to the address of that pointer. And now notice I can get to the actual data by going through that pointer saying, give me the thing pointed to by that, which is going to be this address, and then give me the thing pointed to by that, which is going to be the value 5. So notice the double dereference there. Give me the thing pointed to by the thing pointed to by this double pointer. And so this is 2 dereferences, which gets me from this to that to the actual value. And the output there is going to be 5. And that's all for today. Go ahead and take a look at Lab 4, which will be posted also. And Lab 4, you're going to be doing some stuff with multidimensional arrays. I'll post a separate video next week where I do a little explanation for Lab 4. But I'm going to go ahead and post it so you can get started on that. We are going to have a midterm coming up, not next week, but the following week. So I'm going to have next week, I'm going to have a little lecture that talks about Lab 4, and then as the first class of next week, the second class of next week, we're going to have some midterm review time. I will actually probably come into the classroom, so if you want to show up and ask questions and work through the review thing, I would suggest you do that, and then the midterm is going to be that following week. So take a look at Lab 4. Other than that, stay safe, wash your hands, wear a mask if you're around other people. Basically, stay away from large groups. And if you have questions, send me an email, send me a text message, and I'll do what I can to get back to you as quick as I can. And if you need help, I can always come in and have some office hours. I'd be more than happy to do that. But that's it for today. And if you are struggling, you should probably ask questions. See you soon.